Okay, page 14, exercise H. So first of all, you know that that's a log e function. Okay, you know that's a log e function. It's nature based, so I can derive it directly. But what happened is, you need to find the derivative for that function. And it's hard to find the derivative for that function unless you know quotient rule by now. But even though you know quotient rule, it's still hard to differentiate this equation because you need g dash x over gx. A little bit of revision. What's the derivative of log e gx? It is g dash x over gx. So if I can't find the derivative for the thing in the brackets, I can't find the derivative. But remember, when you do logs, try to simplify the equation because the rule you have is log a m over n equals to log am minus log an. Okay, that's the formula. Okay, that's the formula. So you have log e, something divided by something. Okay, so gx can be simplified to log e x squared minus 2x plus 3 minus log e 3 minus x cubed. Okay, you may think that's simply simple enough, but for me it's not that good yet because I can further do a step to make it even simpler. So I still maintain the first one, but the second one, the power, I can drag the power to the front. That becomes 3 log e 3 minus x. Because even though I know the chain rule, I don't want to use it that often. I try to make as simple as possible. So if I drag the 3 into the front, that can make my equation really simple. So why find the derivative of g dash x? Okay, I want to derive the things inside. Okay, derive this inside. So that will give me a 2x minus 2 over x squared minus 2x plus 3. Okay, g dash x over gx. Okay, g dash x over gx. So if I do that, can I simplify that? No, I can't really simplify it. Minus 3 times of the derivative of log e is 3 minus x. Okay, so derive the thing inside the bracket. 3 minus x, the derivative is minus 1. Okay, derivative is minus 1. And 3 minus x under the denominator. So what I will have is 2x minus 2 over x squared minus 2x plus 3 plus 3 over 3 minus x. I don't need to combine them, like that's the derivative. Unless the question asks you to put in a single fraction or like ask you to do some particular form. Otherwise, you can just leave your answer like that. It's the simplest version already. Okay, so the key point for this question is when you derive log, try to separate that because when you divide something, it will be log minus. If you times something, that will be log something plus log something. If you have a power, you can put the power down as a coefficient. So you can simplify log by a lot of ways and then derive that. Okay, do not directly start the derivatives. Have a think about how I can make this question easier. Okay, that's H. Okay, so I haven't finished I, but like I help you to change the base because it got a base of 4. It's not a nature base, so I need to change this base. Okay, if I change this base to e, why I change e? Because I need nature base. So it is log e x squared minus 4x plus 1 divided by log e4. So what is log e4? Log e4 is a constant. Okay, so you will have coefficient 1 over log e4. That's a number. Okay, that's a number 1 over log e4, like a constant, times log e x squared minus 4x plus 1. So now I want to derive it. I will find g dash x equals to, okay, you will have 1 on log E4 still. You still have 1 on log E4, that's the constant, times, okay, derive that. Okay, derive that. When you derive the things inside, you have 2x minus 4. Okay, 2x minus 4, derive that inside, 2x minus 4. Over what? Over x squared minus 4x plus 1. Okay, so if you can combine them, you can say that's 2x minus 4 over log E4 times bracket x squared minus 4x plus 1. Okay, that's how you deal with logarithms without nature base. You need to change of base. Okay, when you have exponential, if it's not a nature base, you use e to the power of log e of that number to change the base to e. But when you have that, you directly use the change of base formula. Okay, j. J is quite simple. I want to derive hx, so you have h dash x. Okay, so you still have the constant there times 3. Derive the thing inside, derive it inside, so you have 4. What sign will change to? Cos, okay, a positive cos. And then you still have whatever you have inside here. So h dash x equals to 12 cos 4x minus 1. Okay, k. Okay, k. Okay, first, h dash x equals to a half. This a half will not change. Derive the things inside. Okay, you directly derive the things in the bracket. So you have negative 4x. Okay, you have negative 4x. What's cosine become to? Negative sine. Okay, you have negative sine 8 minus 2x squared. And then that's 2x sine 8 minus 2x squared. What tangent will become to after derive? Secant squared. Okay, sec squared. Okay, now let's have a look at this question. I don't want to deal with things under the denominator. Okay, if something is on the denominator, I will try to make it into the power form. Because when you make something into the power form, I can use the chain rule. Okay, I can use the chain rule. So for this one, that is obviously gx, right? That's 2 lots of gx to the power of negative 3. Let's have a think about what is g dash x. So g dash x equals to, because you need to derive that. So you have derive the things inside, which give you a 2. Sine will become cosine, and then 2x plus 1. Okay, that's g dash x. So what is p dash x? The 2 will still be here. The first thing is you need to get the power down. You need to times the power, which is negative 3. And then you will derive this gx. So you have 2 cosine 2x plus 1. And what's the last thing? Last thing is reduce the power by 1. Using chain rule, reduce the power by 1. So you have sine 2x plus 1 to the power of negative 4. So what do you have? Negative 12 cosine 2x plus 1 over sine 4 2x plus 1. Any questions about this? Try to make things into power form, because if it's things in power form, it's so easy for me to derive. Okay, I can use chain rule directly. Chain rule gx to the power of n, you have n times g dash x times gx to the power of n minus 1. 3 components, power, original power, times the derivative of that function, and reduce the power by 1. Okay, 3 steps. Okay, next one. Next one is 3 cosine 2x minus 1 to the power of a half. Okay, so I will use p dash x. What p dash x equals to? Okay, gx is the thing inside. I can't take the 3 out. Okay, I can't take the 3 out directly. If you want to take the 3 out, it needs to be a square root 3. Okay, it needs to be a square root 3. Or like it needs to maintain the 3 in the bracket. So first thing is a half. Okay, it's the power of a half. Times the derivative of the inside. Okay, what's the derivative inside? Okay, derive that. The 3 is still there. You derive the bracket is 2. Okay, times 2. And cosine will become negative sign. So you have negative sign 2x minus 1. Okay, that's the derive of g dash x. Okay, g dash x. And the next thing will be reduce the power by 1. Reduce the power by 1, that become negative a half. So p dash x will equals to, okay, a half times that is 1 is negative 3 sine 2x minus 1 over what? Square root of 3 cosine 2x minus 1. Okay, that's all the rules you need to know. That's all the rules you need to know for derivatives. Okay, so we have x to the power of n. We have exponential, logarithm, sine, cosine, and tangent. Okay, that's not a lot. And then we have combination of chain rule, and in a minute we'll learn product rule and quotient rules. Okay, after we learn all of that, you can do VCAP paper. Part 1 exam, question 1 and question 2. Okay, because it's always there. Okay, so after we finish today's lesson, you can go to do all the question 1 in exam 1. Okay, so next one is J and K. It's a really long chapter. Okay, so the product rule. Okay, the product rule and the quotient rule. So this is only 2 rules. I don't need to really tell you why this happened. I just want to tell you how to use this rule. So what is product rule? As I told you before, when you have fx times gx, you can't derive fx and then times the derivative of gx together. It's not the derivative of fx times gx. So what is the actual derivative for like 2 functions times together without expansion? Okay, without expansion. So if you have fx equals to 2 function times together, you have ux times vx. Okay, ux times vx, like you have one function times another function. Then what's the derivative? Derivative will be ux times v dash x plus u dash x times vx. So you keep one function, derive one, plus you keep the other one, and then derive the first one. Okay, so just derive one and keep one, and you add them together. That's the derivative for like fx, ux times vx. Okay, quotient rule, product rule is easy because all that doesn't matter. You derive which one, it doesn't really matter because you plus it anyway. So you just have 2 things and plus them together. But for quotient rule, it's a little bit different. Okay, for quotient rule, the order is important. You have ux over vx. Okay, that's really complex. I hate quotient rule a lot. Okay, because it's really long and it's so hard to mark. Okay, like when you mark the paper, you can't see where's the mistake. And always make, like students always doing this question wrong because they can't remember the formula. That's the big problem. Okay, so what's the derivative? The derivative will be Vx squared. Okay, that's the denominator. So what is the denominator? Denominator will be squared. Okay, denominator will be squared. How you can think about this? You think about, okay, when I have to the power of minus 1, you need to reduce the power by 1. So you have minus 2. Then it's over denominator, so I have Vx squared. Okay, that's why I have denominator squared. And then I think about the numerator. Okay, I can't reason for you for the numerator, but like you just need to remember that. You need to have Vx first times the u dash x. You will derive the numerator first. Okay, derive the numerator first. And you will subtract, derive the denominator times the numerator. So you will derive the numerator first, and then you will derive the denominator, and you need to subtract them. Okay, you need to subtract them. That's why the order is important, because if you subtract in the other way, that will be a negative of that number. Okay, it will be the negative of that number. So what I'm thinking is, I always think about, okay, the denominator will be squared, and then I will drag the denominator to the top. So the Vx will remain there. So I need to derive u dash x. Okay, I need to derive ux first. So that's the formula. You derive the numerator first and subtract, you derive denominator first, and your denominator will become squared. Okay, that's quotient rule. So that's the quotient rule. Okay, let's have a look. Let's have a look. Example 1. Okay, example 1 don't really require, not really require quotient rule or product rule. I can do it this way. That equals fx equals to log e. Okay, I can see that's a half, so I can put a half into the front, and it's a log e 3x minus 2. And I will minus bracket log e 4, subtract log e x squared minus 1. Okay, this bracket is really important. Okay, when you separate log e4 minus log e x squared minus 1, they're together. Okay, that's one thing, they're together. You need to have the bracket here. Then I will have a half log e 3x minus 2 minus log e4 plus log e x squared minus 1. What is log e4? Constant. Okay, constant. So you derive f dash x. You derive f dash x. So when you derive this, you have the half here times. Okay, derive the log e. Derive this is g dash x over gx. So it's 3 over 3x minus 2. Minus log e4. What's the derivative for log e4? What's the derivative for log e4? Zero. Constant. Derivative of a constant is 0. Okay, derivative of a constant is 0. So that's a 0. Derivative log e4 is a constant. You derive that, that will become 0. So 0 here. Plus, derive that is 2x over x squared minus 1. So you have 3 over 6x minus 4 plus 2x over x squared minus 1. Okay, actually I like to derive log a lot, because log is actually, you can simplify the original equation and make it really easy to derive. Okay, so the power can be taken down. If you have times in the bracket, you have subtract in the bracket, you can all make it plus or minus, all separated out. Okay, let's directly look at C. C is not a quotient rule or product rule question either. So I just need to derive the tangent directly. So let's say gx equals to tangent 3x minus 2. What's the derivative for gx? What's the derivative for gx, everyone? What's the derivative for this? 3x squared. What's in the bracket? 3x minus 2. Okay, we have that. Okay, that's g dash x. So h dash x equals to g dash x over gx. But, I will say but, I can do something further to this. What is 3 secant squared 3x minus 2? It's 3 over cosine squared 3x minus 2. Okay, that's the numerator. That's the numerator. I'll divide by tangent x. What is tangent? Tangent is sine over cosine. Okay, so if I can flip this, and I can cancel the square and this, I'll have 3 over sine 3x minus 2 and cosine 3x minus 2. And I think if you learn Spanish, you have learned double angle formula. That looks like a double angle formula. But if you haven't, that's okay. You can keep your answer like that. You can keep your answer like that. Okay, question B. Question B. Gx equals to sine 3x over 2x square 2e to the power of x minus x. That's something derived by something, and I can't simplify it. I can't expand it. I must use quotient rule. So let's say ux. Let's say fx equals to sine 3x over 2e to the power of x minus x. And let's say ux equals to sine 3x. So you know you need to derive that. So what is u dash x? U dash x is 3 cosine 3x, right? U dash x is 3 cosine 3x. And what is Vx? Vx is 2e to the power of x minus x. 2e to the power of x minus x. So what is V dash x? What is the derivative of e to the power of x? Still e to the power of x. Okay, still e to the power of x. So I have 2e to the power of x but minus 1. Okay, you derive x. X will become 1. So that becomes 2e to the power of x minus 1. That's the V dash x. Okay, now you use the quotient rule. You use the quotient rule. So g dash x equals to, okay, to use quotient rule, what's the denominator? The bottom squared. So I have 2e to the power of x minus x to the power of squared. Okay, what's the numerator? Yeah, minus which one in the front? Which derivative in the front? Which derivative? You derive which first? Numerator or denominator? Numerator. Okay, derive numerator. So you have 2e to the power of x minus x. Okay, you just have that's the Vx, and you have the numerator derivative, which is 3 cosine 3x. And you will subtract. You subtract. Okay, now you have the derivative for your denominator as 2e to the power of x minus 1 times sine 3x. But don't forget, you still have a minus 2x here. Remember to minus 2, okay, in the end. You still have the minus 2x there. You derive the minus 2x, that's a minus 2. And I can make this looks a little bit better by, well, I don't want to expand them because there's no meaning if you're going to expand it. So I'll just put a 3 into the front and then times 2e to the power of x. I can write it a little bit here. 3 bracket 2e to the power of x minus x cosine times cosine 3x minus 2e to the power of x minus 1 times sine 3x. Oh, I have no place to write minus 2. Well, let's do this. 2e to the power of x minus x squared. And you have a minus 2 in the front. Okay, that works. That works. Okay, minus 2 plus that thing. And normally in this exam, it's not required you to simplify for this type of question. But if it asks you to simplify, that will be something really obvious, like you can simplify. Okay, you don't need to do like that's very complex. You can leave your answer like that. That's why I don't like to mark the question for quotient rule. Okay, it's so hard to mark. Okay, next one, that's quotient rule. Okay, quotient rule is nothing hard. It's still based on previous lesson what we have learned, how we derive different functions, and plus like we know that formula. Okay, just we know that formula. Okay, exercise D. Okay, exercise D. Kx equals to some function times some function. Let's say we have ux is cosine 3 minus 2x. And we have Vx. Vx is e to the power of sine bracket 1 minus 3x. Okay, the derivative for Vx will be tricky. So let's look at u dash x first. So what is u dash x, everyone? Tell me the answer. What is u dash x? Positive 2 sine or negative 2 sine? Positive, because you have negative 2 and negative sine. You have negative 2 and negative sine. 3 minus 2x. So that is 2 sine 3 minus 2x. Okay, let's have a look at v dash x. How you can derive this function? How we derive u to the power e to the power of gx? What's the formula first? It's g dash x times e to the power of gx. Okay, so what is the g dash x here? Sine. So you derive it. Negative 3 cos 1 minus 3x, right? Sine will become cos. So you derive this, you derive that, okay? You want to derive that. So you need to derive the thing in the bracket. First is negative 3. And sine will become cos. And you have 1 minus 3x. And then you have e to the power of, still have that power, okay? You always have the exponential itself again in the derivative. Okay, you must have the same component as the original equation in the derivative for exponential. So you still have e to the power of sine 1 minus 3x. Okay, so what is k dash x then? So you know you will do this direction. Okay, you times those two plus you times the other two. u dash x times vx, v dash x times ux. Okay, times them in a cross way, and then you plus them. So k dash x equals to, okay, let's do this side first. 2 sine 3 minus 2x e to the power of sine 1 minus 3x plus, okay, plus a negative 3 cosine 1 minus 3x e to the power of sine 1 minus 3x and times cosine 3 minus 2x. That will just become 2 sine 3 minus 2x e to the power of sine 1 minus 3x minus 3 cosine 1 minus 3x cosine 3 minus 2x e to the power of sine 1 minus 3x. If you like, you can take a denominator for e to the power of sine 1 minus 3x, but it's not necessary. It's not necessary. That's how we use product rule. Okay, that's how we use product rule. Okay, any questions so far for this? If you don't have any questions, let's have a look at example 2. Let's have a look at example 2. In example 2, you have fx equals to gx over square root x. But I haven't tell you what is gx, but it's okay. I give you some values. g4 equals to 8, g-4 equals to 6, and I want to find f-4. So before I want to find f-4, I need to find f-x first. Okay, I see some students, last year students, what they're trying to do, like ask you to find f-4. Okay, they find f4 first, and then they're trying to derive f-4. You can't do this. Okay, it must be derived first, and you put the value in. Why? Because if you put f4 in, that's a number. Okay, the whole thing become a constant. That become a result. And you're trying to derive that result. That becomes 0. Okay, you have no derivative for that point. So you need to find f-x first. To find f-4, I need to find f-x. But before I want to find f-x, let's name that ux and vx. So you know that f-x should equals to vx times u dash x minus v dash x times ux over vx squared. Okay, that's the formula. And let's have a look. What is u dash x? U dash x is just g dash x. Because I don't know the equation, I just use notation to represent that. U dash x is just g dash x. What is v dash x? V dash x will be, that's x to the power of a half. Okay, vx is x to the power of a half. Then I have a half times x to the power of negative a half. That equals to 1 over 2 root x. 1 over 2 root x. What is vx squared? What is vx squared? What is vx squared, everyone? It's not a hard question. What is vx? X. Okay, square root x times square root x. Just have x. Vx is x to the power of 2. You squared it, you just have x. Okay, let's just put all the information I know into f dash x. F dash x will equals to vx. Vx is square root x times u dash x. U dash x is g dash x. Subtract v dash x. So v dash x is 1 over 2 root x times ux. So what is ux? Ux is gx over x. Okay, what I want to do is times 2 root x on both top and bottom. That will gives me, okay, this times 2 root x, you have 2x times g dash x minus, okay, cancel with this fraction, you just have with gx over 2 times x to the x times root x. Let's just leave the answer like that. That's x times root x. So what is f dash 4? F dash 4 is 2 times 4 times, what is g dash 4? G dash 4 is 6, so it's 2 times 4 times 6 minus g4. What is g4? G4 is 8 over 2 times 4 times root 4 is 2. 2 times 4 times 2. What that equivalent to? 40 over 16. Is that correct? I have 2 times 4 is 8. 6 times 8 is 48. 48 minus 8 is 40. 40 divided by 16. I will have that divide by 8. I have 5 and divide by 8. I have 2 here. So it's 5 on 2. It's 5 on 2. Any questions, everyone? I'm not going to continue for the next exercise. Because I give you a lot of formulas during these 2 lessons, Monday and Wednesday lesson, there are a lot of formulas, a lot of calculations. You need to remember all these formulas first, and then we can go for the next exercise.